gotta go through this stuff very quickly. All right, guys, we are gonna get this thing done, and then we're gonna assign homework.
Anthony, are you tutoring for this school today? I heard we all fucking shut up. Someone.
How about me?
Friend Michael, he came up to me, he was like, we all fucking you have a huh?
All right. Shh. What we're gonna do is we're gonna go in through all the stuff. Last period we try to explain the radius of interval convergence. So radius and interval
Another test.
of convergence. No, we are gonna stick with same test, which is the ratio test. Reba, if you're not here, we actually talked about something kind of important last Friday. It's just introduction to power series. You had to go back to watch the video.
Like the video ratio test? Video?
That video doesn't have a ratio test, but we are gonna do ratio test today because to test for radius and interval convergence. Rebuff, I really need you to lock in for the next 3 months. Good. And I, you know. Okay. So you got radius of interval convergence here, and you say, okay, well, anytime you have a power series, you have some domain it will work. Like that domain is called interval of convergence. Because outside that domain, it's gonna be divergent. So you say, okay, that doesn't work, that part doesn't work, but right now we're only gonna focus on the part it works. So we got 3 situations. So last week, we show you this equation is equal to summation of a1 times x to the n equal to 0 and infinity. And we told you that this is represents 1 plus x squared plus x to the third plus x to the fourth, dot, 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 dot. Right? And that just give you some background information from last time. That last time Rebob's not here. So we say this is actually true representation because if I do 1 over 1 minus x, and you say, well, this function is going to look like that, they are equal to, and you thought I'm crazy, but x to the 3 plus x to the 4th plus x to the 5 plus x to the 6 plus x to the 7 plus x to the 8 plus x to the 9 and a plus x to the 10. And we're just going to stop here. It turns out this is a very accurate representation. And this is accurate representation. There is a certain interval that we are worried about. That worry about is going to be from -1 to 1. -1 less than x less than 1. And so in this region, they are pretty close. Right? They are pretty close. If I add more, they will keep on, the curve will keep on matching up. And some people says, well, what if I increase a little bit more? So let's just say 2. After 2 is not accurate anymore. After 1 is not accurate anymore. After -2 is not accurate anymore. The only region that work is called interval of convergence. And that work is between -1 to 1. Is that okay? So between -1 to 1, they get pretty accurate. The more terms I added in the back, the more accurate it's going to be 1 minus 1, 1 minus x. So you say, okay, well, every power series have two things, radius and interval convergence. Now, sometimes some function only work for a single point. So we got three situations. First situation, second situation, third situation. The first situation is the series converge only at C. Only at C, but not anywhere else. So in terms of interval, it's going to look like this, a single point. So this is a single point. So only that single point can be represented by the function. Rest of them doesn't work. Ideally, this is pretty useless, right? It only can represent 1 point. At least the other one can represent from -1 to 1. But this one does only represent one single point. The second situation is this. The series converge at all x. So that means this is every single point. So from -infinity to infinity. Now this one here, radius is what? If it's worth only 1 point, the radius is equal to 0. Is that okay? And this one's radius is what? Infinite, because it works from -infinity to infinity.
What does the point say for the first one?
Single point.
Oh, single.
Now, you can also have the third situation, which is most of exam on AP exam, they only worry about from which interval to which interval. So there exists a real number r is greater than 0 such that the series converge absolutely for x minus c is less than r, or x minus c is greater than r. One of them is converge, one of them is diverge. So they are radius of convergence, or we also know as interval of convergence. They're not the same. Radius is talking about from center to the edge. Interval is from edge to edge, from the end to the other end. Yes.
So that one would definitely converge, or you said either of them could be either one?
3 or 2 or 1.
Three. You said
There exists a real number r is greater than 0, such that the series converge absolutely. For this to converge, this is diverge. This doesn't work. This is diverge.
okay.
So this situation is diverge. If it's greater than r, it's going to be diverge. Now let's talk about the first situation. So let's start by radius of convergence. We are going to find radius of convergence of this. N equal to 0. And in this case, it's infinity n factorial x to the n. So what happened if f of 0 here? F of 0, just plug in 0. N factorial 0 to the n. That's just going to be what? 1. Zero factorial is 1, right? Plus 0 plus 0 plus 0 plus 0. That's equal to 1. So the best test for radius convergence and interval of convergence, you're gonna do a ratio test. What does a ratio test tell you? If the next term over the original term is less than 1, the series converge or diverge. Is less than 1. It's a converge, right? So then you say, okay, well, let's just limit n approach infinity of a to the n plus 1 over a to the n, which is equal to limits n approach infinity of n plus 1 factorial times x to the n plus 1 all over n factorial times x to the n. Limits n approach infinity. Here we can simplify this. How do I simplify n plus 1 factorial over n factorial? Can I rewrite a n plus 1?
Plus 1
Times n factorial. Good job. N factorial. And this is x to the n times x over x to the n. So this cancel out. This cancel out nicely. Limits n approach infinity of n plus 1 and absolute value x. Now, why did I put absolute value x in the front? Because the limits only n approach infinity, not an x. So x is just a constant. Now, if n approach infinity, what will happen? This result with what? This result is going to be what? Infinity. Good job. Now, so it doesn't matter how x is. If x is some type of number greater than 0 or less than 0, it's automatically going to go to infinite. Because infinite times some fixed number is going to be infinite. So therefore, this one's infinite. If it's infinite, that means they only can converge when x is equal to what?
0.
Yep. Only converge when absolute value x is equal to 0. X equal to 0. So that means radius radius of convergence is equal to 0. So there's no radius. Only work on one point. At 0, my output's 1. Other point does not work. It does not work whatsoever. I'm gonna let you try another one.
What is the radius in convergence?
Okay, so last week we talked about power series. Power series can be represented. So let me see if I can get the last week's notes. Nope, it's too long ago. I think here. Yeah. So I'm just gonna give you a fast breakdown. So power series is like this. It's basically a series with an x in there. And it could be x to the n or x minus c to the n. The an is a series. This is first time we bring a variable into the series. Now remember, this is just some type of series I can represent. Usually we don't have x. Now we have x in there. Now, obviously, this one is equal to summation of x to the n is 1 plus x squared plus x to the third plus x to the fourth. Does that make sense? This is some type of geometric series because each time you multiply by x, you multiply by x here, you multiply by x here, you multiply by x, you multiply by x. So if it's multiplied by x, I can write this series in terms of this. Why? Because it's geometric. This is your first term. This 1 minus r. R is the x. So it'll be 1 over 1 minus x. So 1 over 1 minus x is equal to this series. Is that okay? Now, you can see that it's true when we look at the graph. We got 1 over 1 minus x. Only work from -1 to 1. It does not work outside 1 because if you see here, these two graphs, they are exactly identical. This is 1 over 1 minus x. And this is 1 plus x squared plus everything. But if you see this, if you go outside the radius convergence, let's say 2, and you see here, it's automatic, it's not matching. So only work from -1 to 1. Does not work at any other place. So that's called radius convergence and also interval convergence. Interval is from where to where. Radius is what is the center. So I'm going to get to here. So in this case, the radius convergence only 0. So that means only work on a specific point. It doesn't work any other point besides that point. Austin, do you understand? Austin, do you understand? So in this particular power series, only work at x equal to 0. It doesn't work anywhere else. It cannot have a true representation of it's only work on one single spot. So it's pretty useless. Now what we're going to do is we're going to go to the next one. We can say, hey, what if I give you a power series looks like this? Now obviously, I can do a ratio test. Why do I choose ratio test? Because ratio test can help me to test, are they converge? Are they diverge? But we only care about are they converge? Because we only care about are they less than 1? So we're going to do a ratio test here. So via ratio test. Anytime I want a radius convergence or interval convergence, I'm going to use a ratio test. So use the ratio test here. It'll be 3 to the x minus 2 to the m plus 1 over 3 to the x minus 2 to the n. Limits n approach infinity. Obviously, this 3 cancel out. It's equal to limits n approach infinity of x minus 2. That's it. So if you see here, it doesn't matter the n. But then it matters what x value now. Which x value is going to tell you are they converge or not. What is my center? Center is what? Center is 2. Good. What's my radius of convergence? No. Remember, it's less than what? If you do ratio test, has to be what? No. Less than 1. So what's my radius? My radius is 1. The interval is not really 2 because if you solve for it, right?
Wait, wouldn't it be 3? Because
Yeah, we're gonna go ahead and solve it. So right now we find the radius convergence is 1 because we're gonna go solve it. If we solve it, it's gonna be x is greater than 3 and x minus 2 is less than, no, it's greater than negative 1. So x is greater than
wait, hold on.
1
How do we know the radius of convergence is 1?
because this part is 1.
So it's always gonna be 1?
No, depends. Sometimes it doesn't always equal to 1.
Why is it 1 in this?
I'm going to show you here. If I have at 0, 1 works, right? And 3 works, right? The center is at here. This is the radius, right?
Okay.
Which is 1. Because we just figured out it's from 1 to 3.
So it's half of the center?
No, it's a half of the intervals.
The interval is 2. Then
Intervals 2.
we find out the 1 to 3, what is that called? The interval.
That's called interval convergence.
And in order to find the radius, we have to do half of that.
It's a half of that.
But then-
Because that's like asking radius interval convergence is like a diameter.
Then how do we find the interval?
Interval, we just basically solve for this thing because we solve for the ratio test.
Okay, but
And
where
we
do
want
get
a
one
ratio,
from?
we want to resolve the ratio test less than 1.
So we always use less than 1 for the ratio for
Yeah, because the ratio test, if you do the ratio test correctly,
less than 1
it has to be less than 1 in order to converge.
Okay. Then where do we get that negative 1 from?
Because this is how you solve absolute value. You drop the absolute value,
Oh,
set it less than 1, or you drop the absolute value, set it greater than opposite.
Still confused with how you get the radius of convergence. Do you find that first before you find the interval?
Radius of convergence usually here is 1. The only time it's not 1 if something like end result you got this 2, then your radius convergence might be just your radius convergence will actually end up to be 2 because you want to multiply 2 on both sides. But this is your center, right? We talk about this x minus 2 is your center. 2 is the center.
But I don't understand.
The other number is going to be your radius.
but like when you were solving this, you got the radius of convergence before you found the interval. How'd you do that?
Because I figure out this is a 1. This is going to tell me that this is the radius. Remember, this is
But
a...
we always use 1, so it's always gonna
Remember,
be 1.
is this the radius here?
Yeah.
So reason why it's less than 1, no, the radius is not always less than 1 because we're going to give you a different situation. It's going to be different. If I have something like the end of my ratio test, I got this, right? I got this, right?
Then it'd be 4.
Then that's going to be 4. Yeah, because you multiply 4 on both sides. So your radius convergence is going to be 4. So like this. But you got x minus 3 greater than 4. So that's going to be x is greater than 7. Or you got x minus 3 less than negative 4. It's going to be x less than what? Negative 1. So it's going to go from negative 1
Oh,
to 7. So what is my center? My center is going to be 3, right? And the radius convergence is 4, and this side is 4. So there's a 4 on each side.
Okay, yeah, but my question, we always use 1 for this test.
Yeah, for ratio tests.
Okay.
The reason why it's not always use 1 is the reason because the ratio test says your next term divided by original term. If the limit approaching infinity is less than 1, it's converge. We only interest on area that's converge.
less than 1 is
Less than 1 is converge. Yes. Okay, so that's what you need to know. So we're gonna do another ratio test.
Wait, so is there a chance, or what would it look like when it's like a problem that isn't less than 1?
Yeah, we're gonna show you that. We're gonna show you other situation. So we're gonna say n equal to 0, infinity, negative 1 to the n, x to the 2n plus 1 over 2n plus 1 factorial. Okay, so this particular case, we are gonna give you this situation. And if we want to find out interval convergence, the only way to do it is using ratio test. So I want you guys to try the ratio test now. Now the ratio test of this particular one might need some practice. So I want you to try before I start it.
We don't, for ratio test, we don't have to do the alternating, right? We can just because negative one will cancel.
Negative one can cancel due to the absolute value.
Oh,
It's not due to other things. But the negative one's pretty important for later to test the endpoint. So don't just easily get rid of them unless you're absolutely sure that while you're doing the ratio test, the negative one's always gonna go away.
So in this case, it would be 2n plus 1 over y.
Yeah, this one you gotta be careful because every time you substitute the n, it's 2 times m plus 1 like this. So there is the order operation difference there. So let's just say if I have limit n approach infinity, negative 1 to the m plus 1, right? Okay, I'm gonna let you do it. Right. Curious how you're doing. Yeah, you can give it one check mark for the star. Oh, actually, one second. Oh, okay. So you can give it one check to solve correctly, but the still. I'll look at it. You got iPad?
Oh,
I didn't know you have iPad.
yeah, but you got that since like 2 months ago.
Really? Too many people have iPad can't keep a track of it.
You'll look over it and stuff, just point out where it's wrong. Okay. I'm new. at
That's
this.
okay. Okay. The thing is, like, you also see like what other people will make those mistakes, but you don't want those people to confuse you too. You understand what they did? Like usually they forgot a chain rule. What I just talked to Sydney about is chain rule is the biggest problem. It seems like. You doing okay?
You do like a little crash course of the Daniel. He gave me like a little crash course on ratio test.
Yeah.
But like I couldn't watch back at the stream because like it was too long. And I cut off.
Oh. Okay, so I'm gonna do absolute value -1 to n plus 1 times x, but you had to plug in n plus 1, so it'd be 2n plus 3. Does that make sense?
Uh-huh.
Okay, over 2n plus 3 factorial over -1 to the n x to the 2n plus 1 over 2n plus 1 factorial. So this -1 and -1 cancel out just because the absolute value. Now this is x to 2n, x to 2n cancel out, so you're gonna get x squared left. Does that make sense? Well, actually, I'm just gonna 2n times x3. I'm gonna do that. Over, be careful with this one, it'll be 2n plus 3 times 2n plus 2 times 2n plus 1. Does that make sense? Factorial over x to the 2n times x over 2n plus 1 factorial. There's a reason why I stop at 2n plus 1 factorial, because this can cancel and this can cancel. So eventually it's going to get this cancel. So that's going to be x squared over 2n plus 3 times 2n plus 2. So then what happened is limits n approach infinity. The way kind of think about it is this: x squared times limits n approach infinity of 1 over 2n plus 3 plus 2 plus 2n plus 2. So if you think about it, x is some type of fixed number, right? So let's just say x is equal to 100. 100 squared is going to be, I don't know, 10,000, whatever. And then you divide it by, if the bottom go into infinite, what will happen? It's 0. So in this case, what's my radius of convergence? Is it infinity? Why is it equal to infinity? Yeah, it doesn't matter what I plug in for x, right? I can plug in x for anything, then still gonna be exactly divided by infinite.
Can you go back to like the first part of the function? I think I wrote something down. It was -1 it's x to the 2n 1 all over. So if limit n approaches infinity of that infinity equals 0, that means the radius is infinity.
Yeah, radius is infinity because it doesn't matter what I plug in there. It's all gonna be less than 0 or less than 1 because the bottom is infinite. The top part is some type of number because it's not x approaching something, right? It's just x squared. So it doesn't matter what value I plug in, divided by the infinite, it's still gonna be less than 1. Okay, so the next case we're gonna say, so instead of find radius, we're gonna find the interval of convergence. So interval is gonna be find interval convergence.
Mr. Yu, what about if x was infinity? Wouldn't that make it like 1?
But x is some type of number. We have to plug in x as some type of number. The bottom just gonna be keep on expanding, so it doesn't really matter.
X also keep on expanding?
No, x is some type of number right now.
So it's constant?
Is it right now is a constant because only n is expanding.
Okay.
So pay attention to at the endpoints. To endpoints. Why do I say that? But first of all, we just start with something that's relatively easy. So that's a summation of n equal to 1, infinite of x to the n over n. And we say, hey, let's find interval convergence. Obviously, the only way that we can do it is using ratio test. So we're going to try the ratio test here. And now we're going to say, okay, well, it's xn plus 1 over n plus 1 over x to the n over n. And then approach infinity, x to the n plus 1 over n plus 1 times x to the n. This will actually cancel this out. And this is step for the x. And then you will get limits n approach infinity of n over n plus 1. And this is x. Why do I put an x in the back in the front? Just because this x is some type of constant. Because the x is the we want to find out where from where to where is defined, right? Now what happens if we reach infinity here? Y is equal to 1. I can divide it by n on both on top and bottom, right? So that's equal to absolute value x times 1. Is that okay? So remember, absolute value x times 1 must be less than 1. So my interval is between -1 to 1, right? Might go too fast. So -1 to 1 because absolute value x is less than 1. If they are less than 1, the ratio test says converge. Is that okay? Now your radius is going to be from -1 to 1. Why? Because you can solve for it. So x less than 1, so that means x is less than 1 or x is greater than -1. So that's going to be less than 1 but greater than -1. I solve it. I solve this inequality. Once I solve it, then you say, oh, okay, well, that's to try out, see what happens. But you must check the endpoints. Must check the endpoints because sometimes you got a situation where the endpoint is converge or diverge. Depends on scenarios. What I mean by scenario is I'm going to go back and plug in -1 for x. What happened when x equal to -1? Summation of n equal to 1, infinity of -1 to the n over n. Is this converge or diverge?
Is there supposed to be an x function?
It's n.
X to the n or negative 1 to
I plug in the x. Is that converge or diverge? Converge why? Alternating harmonic series or alternating series tests. Right? Either way, that this one's converge because alternating harmonic. So therefore, this one's converge. So how about x equal to 1? X equal to 1 is going to be what? If I plug in 1 to the n, why is that diverge?
It's less than.
No, it's not because less than 1, it's because what? Harmonic series? Or p series, either p series or harmonic series, because n is equal to 1. N equal to 1 is diverge. N is greater than 1 is converge.
Is n and x the same thing here?
No, because we only plug in the x. We plug in the x right here, -1.
Oh, yeah. Wait. Less than.
No, greater than 1 is diverge. Interval of
No,
convergence? No,
less than 1 is diverge.
no. P series when n is greater than 1 is converge. Less than 1 is diverge.
Yes.
Okay, I thought you read something else. Interval convergence is gonna be, well, it's including -1, but not including 1. This is the final answer. This is the final answer. Including 1, but not including the other one. But you have to test the endpoint, make sure that's true. I'm sorry.
Oh,
Stress out. No, it's okay. Just leave it there. I'll
I
just
thought
do
one
the
was
rest.
diverge.
Huh?
we're not including.
You want us to
Oh, okay. No, I didn't know what the difference. I thought the straight one meant we didn't include it.
Okay, now you're gonna try one. See what's the radius convergency here, or what's the interval of convergency. So, -1 to the n to the x plus 1 to the n over 2 to the n. Oh, this is really bad. -1 to the n, x plus 1 to the n over 2 to the n. So I want you to find out what's the interval, but also double check the endpoints. If you don't double check the endpoint, sometimes the endpoint diverge, sometimes the endpoint converge. this one is the u, this one's the u prime. Now let's do it to this natural log. So you move to the other side, so you move this way. So you actually get this two number. And this is what it's taking away too. So
Because like there's like all the ends cancel out.
oh, he did very. Oh no, he did. So if you see this, right? So this is to the 1/2
I mean, you
power.
got, you
So 1/2 power
you got that.
cancel this. This is like 2 times
That's,
the 1/2 power on the bottom. So it will be the same answer.
Oh, okay.
So this person actually did that for the pleasure. It's okay. It's part of understanding how things work.
Is that it? I mean, if it's alternating, like if it's,
I'm here until 3.
what do you call it?
I just want you to go for all this.
If it's oscillating between 1 and 8, that's.
You need help or something.
Oh, no, no, it's okay. I mean, I don't. What you get?
No, I got that.
Are they both diverge or are they both converge?
I don't done that. Both diverge.
Reverse on test today, man.
You got it.
You're supposed to find the center.
I mean, you can.
You can find the center if you want.
Did you find center?
I mean, it should be pretty.
Wait, so what if it's like an x plus one? The center be 1 or negative?
I think the center.
Wait, so this is negative. This is negative. So this would, in this case, is, oh,
Yeah, but if you put -3 in, you get -2, which is just. Or actually, wait. But yeah. Because you would get 2 of 2.
well, this still diverge.
Does? Or it's equal.
You put it, they don't come like that.
It would be 2 and
One to,
Exactly.
yeah, 2 over here.
yeah, 1 to the n, 1 to the n.
Now you're gonna say it to yourself so you get more change facts to internal you.
What's it called? Which one's that? I don't know, one of them. Yeah, do we plug these in for
Yeah.
X? I think. So this, do we plug this into X?
Yeah. Oh, yeah, yeah, yeah.
How do we figure out if it's converged or diverged? Do we just like evaluate it?
Straight there.
Okay.
Fine.
I'm looking at the series. Converging down.
What is the left hand side? -3.
Where are you? Like what? How do you break?
For another great Titan day.
So
You are now dismissed.
the work will end up being like this. Now, why is that diverged? Because if you just add 1 infinite amount of time, it's still diverged. It's still going to go infinite. -1 to the n is going to be diverge. Tony, you actually passed. You passed. You passed with 60.
Negative the x plus 1 over 2 is
That's actually better than a lot of people are.
They just wanted me to ask.
I don't know. We're still processing. Just help me grade.
Should be the word.
And let me throw my foot away.
Wait, could you go up?
Yeah.
So
Wait, how does this cancel out?
Absolute value. Absolute value cancel
Negative-
anything.
The negative one left over. Cancel out.
Because the absolute value of -1 to any power is gonna be cancelled out.
the negative inside that you kept, it doesn't matter. The answer was still correct. It doesn't matter. But where yeah, so he went to here.
Where's it put it from?
So this is like where you were. Absolute value x plus 1 is less than 2.
Negative x plus 1 over 2 less than 1. Do this. I'm supposed to do that.
Yeah.
It's not too bad. It's easy, right?
Yeah.
But it's easy for you doesn't mean it's easy.